There is a paradox that few people realize. The most terrifying universe is not found in places where something is destroying everything, but in places where there is nothing at all, and in places where something exists, but we cannot see it. True fear does not come from destruction. It comes from the helplessness of perception. Tonight we will travel through regions of space where light rarely reaches, places where galaxies are so lonely that if the Milky Way were placed in the middle, it would have no neighbours for hundreds of millions of light years. Places where invisible forces are pulling thousands of galaxies toward them, but we cannot see what they are. Places where time stops, the laws of physics collapse, and monsters with the mass of an entire galaxy sit motionless in the dark. And among all the places we're about to visit, there is one place, one thing, that may change the way you see your entire existence. And I'm not talking about a black hole or a void. I'm talking about the final boundary. A boundary where, when you stand before it, you realize that everything you once thought was reality is only a tiny dream. Before we begin, as always, I would love to know where in the world you're listening from and what time it is where you are right now. If these stories can keep you company as you fall asleep, subscribe to Space Lull. One journey every week, and with each journey, a new kind of peace. And now, let yourself drift into the first emptiness. One. Boötes Void, the void of cosmic loneliness. Imagine waking up in a dark room. You open your eyes, you look around. There are no walls, no ceiling, no floor, nothing at all. You're floating in an endless emptiness. You look down at your body. You're still there, still breathing, still alive. But around you in every direction there is only darkness. Deep, silent, bottomless darkness. You raise your hand in front of your face. You can see it, but you cannot see anything else. Not a single ray of light from distant stars. Not a faint blur of a nearby galaxy. Not one point of reference to tell you where you are, whether you are moving, or whether you have been standing still for a very long time. You try to scream. There is no sound, no air to carry your voice. Your mouth opens, but nothing escapes. Only absolute silence, wrapping around you like a thick layer of black water. And then you reach the most terrifying truth of this place. Even if you called out forever, no one would hear you. Not because they choose not to hear, but because between you and the nearest living being is a distance so vast that even light gives up along the way. You've not been abandoned. You're simply too far away to ever be found. That is the Boötes Void. Not a place you visit. A place that swallows every idea of being with someone. The Boötes Void was discovered in 1981 by astronomer Robert Kirshner and his team. They were doing what seemed like ordinary work, measuring the redshifts of galaxies to determine their distances. But when they aimed their telescopes toward the constellation Boötes, they realized something strange. There were no galaxies. They checked their instruments. They counted again. They looked one more time. There were only a few galaxies scattered along the edges, like people standing on the rim of a cliff, looking down into a bottomless abyss. They had just found one of the largest structures humanity had ever known. And inside it was almost completely empty. The Boötes Void is about 330 million light-years across. To help you feel that number, if you stood at one end and looked toward the other, light would need 330 million years to cross that distance. When that beam of light began its journey, the first creatures were still crawling out of Earth's oceans. Inside that enormous void, scientists have found only about 60 galaxies. 60. While a region of space the same size elsewhere would usually contain thousands of galaxies, the density here is dozens of times lower than the cosmic average. Let that sink in. If our Milky Way, with its 200 billion stars, with every planet and every possible form of life within it, were placed at the center of the Boötes Void, then here is what would truly send a chill down your spine. Astronomers on that planet, if they existed, would look up at the night sky and see it completely empty. They would grow up believing that the universe contained only their galaxy. They would never know that trillions of other galaxies existed out there, because all of them would be too far away to see. No Andromeda 2.5 million light-years away. No friendly galaxies in the local group. Not a single signal from distant civilizations. Only darkness. And here is the final terrifying layer of the Boötes Void. We still do not know for certain why it exists. Scientists have a few hypotheses. Some believe it formed from the merger of many smaller voids in the early universe. But that idea still cannot fully explain why this region is so empty. And it is the void in our understanding that makes this place so haunting. Because when we stand before something 330 million light-years wide that we cannot explain, we are forced to admit the universe was not designed to make humans feel comfortable. Some regions of it are simply absence. Absence of light, absence of matter, absence even of answers. The Boötes Void is a reminder that being together, being surrounded by light, by matter, by life, is an incredibly rare treasure in the universe. And tonight, you have it. It is the loneliest place humanity has ever known. 2. Eridanus supervoid and cold spot. The cold scar of the universe. If the Boötes Void is an ocean of loneliness, then the Eridanus supervoid is something entirely different. A cold region carrying a mark that no scientist on Earth has been able to fully explain. Boötes frightens you because of absence. Eridanus frightens you because it may be a scar, and we do not know what left it behind. Eridanus was not discovered through the light of galaxies, but through the absence of something else. To understand that, we need to talk briefly about the oldest light still remaining in the universe. After the Big Bang, the universe was so hot that light could not travel far. Particles constantly collided with one another, forming an opaque plasma. About 380,000 years later, the universe cooled enough for atoms to form, and light was released for the first time. That light, the cosmic microwave background radiation, is still travelling through space today. It is a fossil image of the universe's infancy. When scientists first made a detailed map of this radiation, they noticed something unusual. In one region of the sky, the temperature was slightly lower than its surroundings, a cold spot. A darker, fainter, colder patch in the background fabric of the universe. It became known as the CMB cold spot. For many years, scientists debated its cause. Some said it was simply a random statistical fluctuation. Others were not satisfied. Then, when they looked deeper into that region with more powerful telescopes, they discovered something that made the back of the neck go cold. That region had almost no galaxies. Behind the cold spot in the sky was a truly enormous void. The Eridanus supervoid, not only empty, but cold. It lies about 1.8 billion light-years away from us, and stretches nearly 1 billion light-years across. Far larger than the Boötes Void. But what makes it frightening is not its size, but the connection between it and that cold spot. Scientists proposed one hypothesis. When the cosmic microwave background light travels through a vast void like Eridanus, it is affected by the expansion of space. Its energy gets stretched, causing its temperature to drop slightly. This is called the integrated Sachs-Wolf effect. In other words, the cold spot in the sky may simply be the shadow of an emptiness we are looking through, but one problem remains unresolved, and that is the part that makes this place so haunting. The integrated Sachs-Wolf effect explains only part of the coldness. To explain the full degree of coldness we observe, Eridanus would need to be larger and emptier than what we have measured. Part of that coldness remains beyond the reach of current science, and that is where speculation begins. Some theoretical physicists have suggested an idea that raises the hairs on the back of your neck. This cold spot could be the trace of a collision with another universe. In the multiverse model, the idea that our universe is only one bubble in an endless sea of other bubbles, two universes touching each other could leave an imprint on the background radiation. A cold spot, silent and still, like a bruise left behind from the moment our universe collided with something outside everything we know. It is a beautiful idea, and it remains completely unproven. It is also possible that Eridanus and the cold spot are only a coincidence, a random arrangement that looks like a clue. But whatever the answer may be, realize this. In the night sky that feels so familiar, there is a region we cannot fully explain, a patch colder and darker than the rest. And when we look at it, even the best minds on the planet can only whisper guesses. It is not violence that makes this place frightening. It is its silence before all our questions. Now loosen your shoulders a little and notice the warmth holding your body right now. You are lying on Earth, a small warm planet full of light and life. But that same universe also contains vast cold abysses, regions where, if you were lost inside them, you would vanish from every map, every telescope, every possibility of being found. The distance between the warmth you have and the coldness out there is fragile and precious. When you look up at the night sky, you do not only see the light of stars, you also see the darkness between them, the emptiness we've just travelled through. And you may wonder, is that emptiness truly empty, or is it only another form of existence that we're not yet wise enough to understand? 3. Great Attractor, the gravitational ghost where nothing can be seen. In the late 1970s, astronomers realized something that kept them from sleeping peacefully. They were mapping the motion of galaxies, a task that seemed simple but revealed a quiet secret. They noticed that our Milky Way, along with thousands of other galaxies, was rushing toward a particular direction at about 600 kilometers per second. 600 kilometers per second. Let that number settle. That is more than 2,000 times faster than a bullet, 50 times faster than Earth's orbit around the Sun. And this is not random motion. It has a destination. Something out there is calling our entire galaxy toward it. And we are not even allowed to see what it is. Because when astronomers looked toward the direction everything was flowing, they met a wall. They called it the zone of avoidance. It is a strip of sky hidden by our own galaxy. Billions of stars and thick clouds of dust within the Milky Way form a curtain that visible light cannot pass through. It is like trying to look through a wall. You know something is on the other side. You feel its weight, but you can never see its face. And the thing pulling us, the thing scientists later called the Great Attractor, lies right behind that curtain. We cannot see it. We cannot photograph it. We only know it exists because everything around it is leaning toward it. This is the unique fear of this place. Not a glowing monster in the dark, but an invisible hand gripping your entire galaxy. And you know it only through its pull, never through its shape. The Great Attractor lies about 150 to 250 million light-years from Earth, toward the constellation Norma, near the centre of a colossal structure called the Laniakea supercluster, our vast galactic home. Laniakea contains about 100,000 galaxies and stretches more than 520 million light-years across. And the Great Attractor appears to be the central gravitational point of that entire structure, the bottom of an invisible valley into which all of us are sliding. But here is where the mystery deepens another layer. When scientists calculated the mass needed to create that pull, they found that the visible mass in the region, galaxies, gas, dust, was not enough to explain it. Something was missing, an invisible mass, possibly many times greater than what we can see, is quietly controlling the flow. It could be dark matter. It could be a massive cluster of galaxies hidden behind the curtain. Or it could be something we have never thought of. Now think about this. Your planet is being pulled by the Sun. The Sun is being pulled toward the centre of the Milky Way. And the Milky Way, the entire galaxy with 200 billion stars, is being pulled toward something no one can see. Right now, while you lie still and breathe slowly, your body is moving at 600 kilometers per second toward a ghost. You feel nothing. No vibration, no wind. The greatest motion of your life is happening in complete silence, and you never knew it. But here is what takes this fear one step further. The Great Attractor may not be the final destination. Recent studies suggest that the Great Attractor itself is also moving. being pulled by something even larger, deeper in the universe. Scientists call it the Shapley supercluster, an enormous collection of about 8,000 galaxies stretching more than 400 million light-years across. And it is pulling the Great Attractor along with everything around it toward itself, meaning if this is true, you're being pulled by something and that thing is being pulled by something else. A chain of invisible hands stretching onward until even our imagination has to stop. I want to make one thing clear so you can feel at ease. The Great Attractor does not threaten us. A distance of 150 million light-years is far too great for it to touch Earth in any way you could feel. You're completely safe where you are lying. But its existence is a quiet reminder. The universe is not a still room filled with motionless objects. It is a vast river of gravitational forces flowing, and all of us are only bright particles drifting with the current toward a place even the greatest minds have not yet been able to name. And that leads us to a deeper question. If the Great Attractor is pulling us, then where is it pulling us to? The answer may be even more mysterious than the question. Something scientists call dark flow. 4. Dark flow. The flow of things that cannot be explained. In 2008, astronomers using data from NASA's WMAP spacecraft, a satellite mapping the cosmic microwave background radiation, noticed something that should not have been there. They were studying the motion of very distant galaxy clusters and discovered that they were drifting toward a particular direction. A direction that no force in the observable universe could explain. The strange thing was not that they were moving. The strange thing was that they were moving together. All the galaxy clusters in the sample, about 700 clusters, spread across 2.5 billion light-years, seemed to be pulled toward the same point in the sky at about 600 kilometers per second. You've heard this number before. The Great Attractor also pulls us at roughly that speed. But here is the part that chills people. Dark flow pulls towards an entirely different direction, toward a destination beyond anything the Great Attractor can explain. The same number but a different hand, in a place far more distant, so far that it may not belong to the universe we're allowed to see. No cause reveals itself. That is dark flow. Let me explain why this is frightening in its own unique way. In the standard model of cosmology, the model scientists have built carefully over decades, matter and energy are thought to be distributed almost evenly on the largest scales. Local irregularities like the Boötes Void or the Great Attractor still happen, but they are exceptions inside our cosmic home. They lie within the universe we can see. Dark flow is different. Dark flow suggests that something may lie beyond the observable universe, beyond the farthest boundary that light has had time to reach us since the beginning of time, silently pulling entire galaxies toward it. Not a galaxy cluster, not a void or a black hole, something outside everything. Imagine sitting in a small boat in the middle of a night ocean. You realize that every piece of drifting wood around you is quietly sliding in the same direction. You look around, no shore, no visible current, no wind. Everything is simply being pulled. And you understand that something farther than the horizon is calling everything toward it. Something you will never see, no matter how long you row. Dark flow could be a sign that our universe is only a piece of a much larger structure. There may be a colossal superstructure beyond the cosmic horizon, massive enough to pull galaxies from billions of light-years away. Or it could be a sign of something even more astonishing. Some theoretical physicists suggest that dark flow may be the trace of another universe, a parallel universe touching ours through gravity. In some multiverse models, many universes can sit beside one another in a larger space, and their gravity may leak across. Dark flow could be the shadow of a neighbouring universe, gently pulling our galaxies toward it. It is a beautiful idea, and it is frightening precisely because it implies that our universe is not everything. It is only an island in a wider ocean, and we are being affected by what lies beyond the shore, by things we do not even have the language to name. But there is another more humble possibility. Dark flow may not actually exist. Some scientists question the data itself. They argue that the effect may be a statistical illusion inside an enormous dataset. Later analyses, including data from ESA's Planck telescope, did not find strong evidence for dark flow. The question remains open to this day, and that is what makes dark flow haunting. Not because we know what it is, but because we do not know and may never know. It is one of the greatest mysteries of modern cosmology, a question even the finest minds cannot answer definitively. Some fears come from what we can see. Dark flow is the fear of a possibility, that whatever is shaping the fate of everything may remain forever beyond our sight. Now breathe out slowly and feel the familiar weight of your body sinking gently into the mattress. You're lying here, safe, in your room, and somewhere beyond everything human eyes and telescopes can reach, something may be silently pulling you along. Not with love, not with will, only with naked gravity. You are being carried gently and irresistibly toward a destination whose name you will never know. And strangely, once you understand that you cannot resist it, there is a kind of peace in letting go and drifting with it. Dark flow, together with the Boötes Void, the Eridanus supervoid, and the Great Attractor, paints a larger picture of the universe, a place full of invisible forces, strange emptiness, and unanswered mysteries. But there is another boundary. A boundary that once crossed you can never return from. A boundary even light cannot escape. And that is where we go next. 5. Event Horizon. The boundary of despair. Event Horizon. The event horizon. It is not a wall, nor is it a surface. A hand passing through it would touch nothing. It is an invisible boundary. A point in space where once you cross it, nothing can return. Not because something is holding you back, but because the structure of space-time there has been bent so severely that every path, no matter which direction it turns, leads deeper inside. The easiest way to understand it is to imagine a river flowing toward a waterfall. A boat far from the falls can still row upstream and escape. But there is a line on the water where the current becomes so strong that even if the boat rows with all its strength, it still slides forward. At that line, the surface of the water is still calm, and nothing has happened yet, but the boat's fate has already been decided. The event horizon is that invisible line around a black hole. It is defined by a familiar concept: escape velocity. To leave the gravity of an object, you must reach a certain speed. A rocket leaving Earth must reach about 11.2 kilometers per second. To escape the Sun, that number is about 617 kilometers per second. But for a black hole, the escape velocity is greater than the speed of light. And because nothing in the universe travels faster than light, nothing can escape from inside, not even light. The event horizon is the boundary where escape velocity equals the speed of light. Outside it, light can still get away. Inside it, it cannot. That is why a black hole is black. Not because it sucks light in, but because light inside never reaches our eyes. But the event horizon is not only a physical boundary, it is also a boundary of time, and that is what makes this place different from anywhere else in the universe. A person watching from far away as their friend falls toward a black hole would witness something strange and deeply unsettling. To the observer, the falling person's time would slow down. Their movements would stretch out, slow as if drifting through honey. Near the boundary, the person would seem almost frozen in the air, suspended there. Then their light would become redder, dimmer, and finally fade away. This is because the light carrying their image is stretched by gravity until the human eye can no longer detect it. To the observer, that friend would hang forever at the edge of the black hole, never fully falling in. But for the person falling, everything is completely different. They would not see themselves slowing down at all. Their clock would keep running normally. They would pass through the event horizon without realizing they had crossed it. No sound, no jolt, no sign. Only when they tried to look back would they understand that the way home no longer existed. That is the truth that makes this place haunting in a very particular way. The event horizon is where the time of two people separates forever. To the person outside, the other has stopped forever. To the person inside, they're still falling. Both are correct, and there is no single true time to decide who is right. In this place, even the question, what time is it now, loses all meaning. For us, time always seems to flow steadily and certainly. Each second is a second, one night following another. But near a black hole, one person's time can diverge completely from another's. 1 minute here could be thousands of years somewhere else. Time is not a single river flowing evenly for everyone. It is a current that can be bent, stretched, and at the event horizon almost stopped. The thing we trust most in life, the steady passing of time, turns out to be relative. And the most terrifying thing about the event horizon is not time, but what it hides. Deep beneath that boundary, inside the heart of the black hole, there is a place where everything we know about the universe dissolves into meaninglessness. A place where the laws of physics collapse. A place where space-time is torn open. A place where even the bravest scientists cannot say for certain what is waiting. It is called the singularity. 6. Singularity, where the laws collapse. Singularity. The singularity is where Einstein's equations stop working. Not because they're wrong, but because they're no longer strong enough to describe what is happening. There, the density of matter approaches infinity, gravity approaches infinity, and the curvature of space-time also approaches infinity. 3 instances of infinity in the same sentence. That is how physicists say, we no longer know anything. And here is what makes this place frightening in a very specific way. Up to this point, every terrifying region we have passed through was still something out there. A void, a pull, a boundary. The singularity is different. It is the place where the very tools humans use to understand the universe are broken. Not an enemy standing in our way, but the map in our hands suddenly going blank. Roger Penrose's work in the mid-1960s proved that the singularity was not an error in the theory, but an unavoidable consequence. Any object massive enough, when collapsing under its own gravity, must create a singularity. His theorem, later expanded by Stephen Hawking, showed that the singularity is the fate of any mass beyond the Tolman-Oppenheimer-Volkoff limit, about 2 to 3 times the mass of the Sun for a dead star. The number can be imagined like this. Compress the entire mass of the Sun into a sphere with a radius of about 3 kilometers, and you have enough to create a black hole. Compress it even further, and you move closer to the singularity, and when its size shrinks to 0, its density becomes infinite. That is the point where the 2 greatest theories of physics meet and fail to reconcile. Those 2 theories are extremely good at what they do. General relativity, the theory of gravity, accurately describes the orbits of planets, the bending of light, and the expansion of the universe on large scales. Quantum mechanics accurately describes how atoms work, how electrons move, and how particles interact on small scales. Each theory is correct in its own territory, but at the singularity, an object as heavy as a star is compressed into a space smaller than an atom. And for the first time, both theories are forced to describe the same thing. They give contradictory answers. Both collapse. This is one of the greatest unsolved problems in modern physics. That is the real reason the singularity is haunting. Not because it is dangerous, but because it marks the boundary of human understanding. We have reached a point where the best theories we have are no longer enough to describe reality. Scientists call this the problem of quantum gravity, and to this day no one has solved it. There have been proposals. String theory, one of the leading candidates for a quantum theory of gravity, suggests that the singularity may not truly be a point. If fundamental particles are not infinitely small dots but tiny vibrating strings of energy, then they may never be compressed into an infinite point, but instead stop at a small yet finite structure. Another approach, loop quantum gravity, suggests that space-time is not continuous but discrete, woven from the smallest possible units, almost like pixels on a screen. If space-time has the smallest pixel, then infinity cannot exist, and the singularity simply cannot exist. Matter would be compressed to that smallest limit and then stop. But all of this remains theory. There is no experimental proof, and here is the harshest part. We will never observe a singularity because not a single piece of information can escape the event horizon to tell us what happened. It is a mystery permanently sealed behind a door that only opens inward. We can only infer, calculate, and speculate forever from the outside. That leads to a deeper question. Does the singularity truly exist, or is it merely a sign that our theories are incomplete? Some scientists believe it is not a physical object, but a gap in our knowledge, a place where the laws we know simply no longer apply. If so, the singularity is not a location, it is a boundary of understanding itself. Whatever the answer, one thing remains certain. The singularity is where the laws of physics stop working, where space and time lose all meaning, where matter and energy become one, and where all our understanding of the universe shatters. There is a contrast worth pausing on here. Right now, everything around us obeys reliable rules. Clocks keep ticking, light follows darkness, tomorrow will come after tonight. That sense of certainty is something we rarely notice because it is always there. But somewhere in the universe, there are points where even that most basic certainty dissolves, where past and future blur together, where the question when no longer has an answer. The peace of a world governed by laws, it turns out, is a gift not every place in the universe has. The singularity is where the greatest machine, our universe, meets a point that even it cannot describe. It is a reminder that no matter how far science has come, there are still things we do not understand, and perhaps never will. But the singularity is not the end of the story. Because while this singularity hides deep inside some distant black hole, another singularity lies right in the middle of our own galaxy, and it has a name: Sagittarius asterisk. 7. Sagittarius A asterisk, the monster sleeping in your backyard, Sagittarius. A asterisk is the name of the supermassive black hole located at the very centre of the Milky Way. It is about 26,000 light-years from us, an enormous distance by human standards, but only a small step on the scale of the cosmos. Its mass is equal to 4.3 million suns, compressed into a region of space so small it is difficult to believe. To understand how heavy that number is, place it beside something familiar. Our Sun is a sphere of plasma more than 1.4 million kilometers wide, large enough to contain more than 1 million Earths inside it, Sagittarius. A asterisk is as heavy as 4.3 million such spheres combined, and yet all that mass is squeezed inside its event horizon, a region with a radius only about 1/5 of Mercury's orbit, an entire sea of mass, packed into a space that light needs only about 1 minute to cross. Its average density, if calculated, is about 1,000 times the density of water, but that is only an average. The deeper you go, the closer you get to the singularity at its centre, and the more the density climbs towards infinity. Sagittarius. A asterisk was first discovered in 1974, when two astronomers, Bruce Ballack and Robert Brown, detected a strong radio source coming from the centre of the Milky Way. They named it Sagittarius A asterisk, the asterisk marking it as a special radio source, unlike anything around it. But it was not until 2022, nearly 50 years later, that humanity truly saw it. That was when the Event Horizon Telescope, a network of telescopes spread across the planet, connected to turn all of Earth into a single lens, created the first image of Sagittarius A's shadow, a faint ring of light surrounding a dark region in the middle. The dark region is where light never escapes. The glowing ring is matter swirling around the black hole, heated to millions of degrees, flashing one final time before vanishing inside forever. It was one of the greatest achievements of modern science. For the first time in history, humanity saw with its own eyes something that had previously existed only in equations. And here is what makes Sagittarius asterisk frightening in a way different from every place we have visited. The previous regions were distant, abstract, somewhere out there. Sagittarius asterisk is right at home. It is the monster in our own galactic backyard. Right now, While everything around you feels quiet and still, this entire planet is orbiting the center of the Milky Way at 230 kilometers per second. And at the center of that vast orbit is this black hole. You feel nothing, no wobble, no sound. Wobble. The greatest whirlpool we are part of happens in complete silence. And Sagittarius A is always there. It was there before humans existed, and it will remain there long after all of us are gone. As we sleep, as we wake, as we grow old, as we pass away. What is frightening about it is not hunger, but absolute indifference. Something so massive that it is not even aware of our existence, quietly anchoring the rotation of an entire galaxy around it for billions of years, never once changing rhythm. Could it swallow the sun at any moment? No. The distance of 26,000 light-years is far too great for us to worry. Here we are completely safe. But its quiet presence is a reminder. Even the things that seem most stable are orbiting something we can never see with the naked eye. And Sagittarius A is not the only supermassive black hole at the heart of a galaxy. Astronomers believe that almost every galaxy has such a black hole at its center, and many of them are far larger than Sagittarius A. When those black holes begin to eat, when they pull matter from surrounding stars and gas into their mouths, they emit light so intense that it can be seen from billions of light-years away. They become quasars. 8. Quasars, the lighthouses of the early age. Sagittarius. A* is silent. It is dormant, a sleeping monster, only occasionally swallowing a star or a cloud of gas that wanders too close. But not every black hole sleeps so quietly. Some are violently active, and when a supermassive black hole truly begins to eat, it creates one of the brightest, most intense objects in the entire universe. That is a quasar. The name quasar is short for quasi-stellar radio source, a radio source that looks like a star. And that name reflects exactly how confused astronomers were when they first encountered them. In the 1960s, astronomers began finding strange objects in the sky. They looked like faint stars, but when their light was analysed, something impossible to explain appeared. Their spectra were redshifted so strongly that no ordinary star could produce it. That redshift meant they were moving away at tremendous speed, and therefore they were extremely far away. In 1963, astronomer Martin Schmidt solved the mystery. He was studying an object called 3C273, the brightest of this strange group. He realized that its spectral lines were hydrogen lines, shifted toward the red, and that the shift showed 3C273 was receding at about 16% the speed of light, placing it nearly 2.5 billion light-years away. For an object at that distance to still be visible, it had to be almost absurdly bright. Schmidt calculated that 3C273 emitted about 100 times more energy than the entire Milky Way. A single object, brighter than our whole galaxy 100 times over. Yet, in a telescope, it appeared only as a faint point of light like a star. That was the moment scientists realized they had found something completely new in the universe. So what is a quasar, really? It is an accreting supermassive black hole, pulling matter from a disk of gas and dust around it. Matter falling into the black hole does not fall straight down, but spirals around it in an accretion disk, like water swirling around a drain. As it spirals, particles collide and rub against one another, and friction heats them to millions of degrees. That heat makes the entire disk shine across the electromagnetic spectrum, from radio waves to X-rays and gamma rays. Part of that energy is focused into jets. 2 streams of matter launch from the poles of the black hole at nearly the speed of light. These jets can extend millions of light-years, farther than the size of the host galaxy itself, cutting through space like 2 gigantic torches carrying the energy of a feeding black hole. Its scale exceeds everything we're used to comparing. A single quasar can radiate more energy than all the stars in its galaxy combined, shine brightly enough to be seen from billions of light-years away, and be powered by a black hole that may weigh more than 1 billion suns. And here is what makes quasars frightening in their own way. If a quasar ignited inside our galaxy, if the sleeping Sagittarius A suddenly woke and began to feed, its radiation would sweep across Earth and erase life in an instant. The ozone layer would be torn apart, the atmosphere scorched, the oceans boiled, and everything would end before anyone had time to understand what was happening. The fear here is not darkness, but light. Light so intense that it becomes destruction itself. But there is a very real reason to feel calm. Almost all quasars are extremely far away. Not only far in space, but far in time. They belong to the early universe, when galaxies were young and black holes were still devouring the matter around them. Their light takes billions of years to reach us, so what we're seeing is actually the distant past. Most of those quasars have long since gone dark today, having consumed the material around them and fallen into sleep, much like our Sagittarius A now. In that sense, quasars are like lighthouses of a bygone age. Their light still reaching us from a young universe that no longer exists. We observe them safely from a great distance, across billions of years, but a few still burn, and one of them is a monster so vast that it challenges every limit humans have ever imagined. It is called Ton 618, 9, Ton 618, King of the Monsters. You may have thought that Sagittarius A*, the black hole with 4.3 million solar masses at the centre of the Milky Way, was something unbelievable. You've also heard about quasars, active galactic nuclei that shine brighter than hundreds of ordinary galaxies, devouring matter with an insatiable hunger. But all of that is only a stepping stone into another realm, where numbers become meaningless, and fear does not come from explosions or flashes of light, but from the absolute silence of an entity so large that your brain cannot imagine it. Ton 618 is not an ordinary black hole. It is classified as a hyperluminous quasar, an extremely bright quasar, meaning it emits thousands of times more energy than a typical galaxy. But the difference is that the thing powering it is not a medium-sized black hole, but a monster estimated to have a mass of around 66 billion suns. The number 66 billion means nothing to human intuition, because we did not evolve to understand such supercosmic scales, so let us turn it into a comparison. If Sagittarius A* were a grain of sand on a beach, Ton 618 would be a rock 15 kilometers across, meaning it is 15,000 times more massive. Its event horizon is about 1,300 astronomical units in diameter, roughly 20 times the distance from the Sun to Pluto. If you place Ton 618 where our central star is, the entire solar system, from Mercury to the Kuiper Belt, would fit inside that horizon, and even light could not escape to tell you what was happening. But the true fear begins when you understand its history and distance. Ton 618 lies 10.4 billion light-years away. The light our telescopes receive today left it when the universe was only 3.2 billion years old, a time when the first galaxies were forming from primordial gas clouds. That means, when you look at Ton 618, you're not looking at the present, but at a ghost of the distant past. Billions of years ago, it emitted ultraviolet radiation and X-rays so powerful that they could ionize the intergalactic medium for millions of light-years around it, preventing new stars from forming in nearby regions, a phenomenon astronomers call quasar feedback. That destruction happened long ago, but its shadow is still traveling through space, reaching your eyes today, and you can do nothing to change or avoid it. The most terrifying thing about Ton 618 is not that it is hungry or violent. No, it is not hunting you, stalking you, or planning to destroy humanity. The fear it creates is far more philosophical and cosmic. The fear of absolute vastness, the helplessness of standing before an entity whose size and energy make every human effort seem absurd. Think about it. The total energy Ton 618 releases every second is equivalent to millions of supernova explosions. Yet it does not explode. It simply eats and emits radiation silently, like a perfect machine operating since the dawn of time. You've had worries about work, money, relationships. All of those things, placed beside Ton 618, are no different from dust on a tiny planet orbiting an ordinary star at the edge of a spiral galaxy. The universe does not hate you, but it does not care about you either. And Ton 618 is the clearest proof of that indifference. It has existed and ruled a corner of the universe since before life appeared on Earth, and it will continue to exist after Earth is gone. It does not see you, does not know you, but its presence is like a gigantic bass note filling the void, reminding you that you're only a tiny pixel in the larger picture. There is another factor that deepens the fear. Ton 618 challenges our scientific models of black hole formation. At 66 billion solar masses, it far exceeds the theoretical limit for accretion speed, the Eddington limit, because by calculation, a black hole should not be able to grow that large within the first 3.2 billion years of the universe. Perhaps it formed through an entirely new mechanism, such as the direct collapse of enormous primordial gas clouds, bypassing the star stage. But for now, that is only a hypothesis, and the fact that you cannot explain it increases the unease. You usually seek safety in knowledge, but Ton 618 stands there like a gigantic question mark, proving that your understanding is still far too primitive. It is an intellectual fear, the fear of your own ignorance before a universe that is always one step ahead. However, take a breath for a moment. Ton 618 is extremely far away and there is no way for it to affect us. But ironically, that safety only increases the fear because if something like this can exist 10 billion light-years away, then how many other terrifying things are beyond our ability to observe? Or worse, much closer than we think. As for Ton 618, think of it as the king of darkness. A cold, indifferent king who needs no throne, no subjects, only space-time bent around it. But do not feel safe too quickly, because even this king may have a rival, an entity larger, more mysterious, and more terrifying, one that astronomers have only begun to whisper about, Phoenix A asterisk. 10. Phoenix A asterisk. A thing so large it should not exist. If Ton 618 made you shudder, then Phoenix A asterisk will make you feel as if you're standing at the edge of an abyss that even science does not dare look into. Phoenix A. Asterisk is not just some distant object. It is a supermassive black hole located at the center of the Phoenix galaxy cluster, about 5.7 billion light-years from Earth. But what makes it extraordinary and terrifying to the bone is its estimated mass, about 100 billion suns, roughly 1.5 times larger than Ton 618. But be careful with that number, because it has not been measured directly. It is inferred from models and indirect data with an uncertainty that may reach 40%. That means Phoenix A asterisk may be only 50 billion solar masses, or it may reach 150 billion. And this uncertainty, the faint shadow of a monster you cannot measure precisely, is the true source of the deepest fear. You're standing before something unimaginably large, but you do not know exactly how large it is, and that is worse than knowing a terrifying number precisely. Try to imagine the size of Phoenix A asterisk if it were located where the Sun is. The diameter of its event horizon would stretch to about 2,000 astronomical units, far beyond the orbit of Pluto, and would cover the entire Oort cloud, the region containing billions of long-period comets, in eternal darkness. To picture it more clearly, if your Earth fell into Phoenix A asterisk, it would not be crushed in the ordinary way. It would be stretched into a strand of plasma thinner than a human hair in 1,000th of a second by extreme tidal forces. Even ordinary stars would be torn apart before reaching the horizon, and their gas would merge into an accretion disk heated to millions of degrees, emitting X-rays powerful enough to illuminate the entire galaxy cluster. Phoenix A asterisk is in a highly active state, and the energy it releases is thought to be enough to heat the gas throughout the Phoenix cluster, preventing that gas from cooling and suppressing the birth of new stars, a large-scale feedback effect that can change the evolution of hundreds of nearby galaxies. The fear here is not that it will eat you, but that it has the power to control an entire galactic environment, something you can only observe like an ant staring at a forest fire. But what truly troubles scientists, and gives you goosebumps, is that Phoenix A asterisk challenges our entire understanding of cosmic evolution. According to standard models, a black hole should not be able to reach 100 billion solar masses within about 8 billion years from the Big Bang to the time we observe it. The Eddington limit on accretion speed shows that a black hole, even while continuously consuming matter at maximum efficiency, can only double its mass every few tens of millions of years. To reach 100 billion, it would need a super Eddington accretion mode lasting billions of years, something current physics cannot explain. Or it may have been born with an enormous mass from the start, through the direct collapse of a primordial gas cloud as massive as a small galaxy. But whether such a cloud could exist without fragmenting into smaller stars in the early universe remains an unanswered question. You see, Phoenix A asterisk is not just a black hole, it is a time machine, a living artifact showing that the rules you think are fundamental, such as the maximum growth rate of black holes, may only be rough approximations in a universe still full of mystery, and that lack of understanding creates a new fear, one that does not come from outside but from inside your own perception. You often think science is moving in the right direction, that eventually humans will explain everything. Phoenix A asterisk is different. It laughs at your models. It exists whether you can explain it or not. It does not need you to believe in it. And it is proof that there may be countless other Phoenix A asterisk objects hiding in unseen corners of the universe, or even things larger still beyond your imagination. This fear is like the fear of a child playing on a beach without knowing that beneath the ocean floor are gigantic whales and deep trenches, and suddenly realizing that the sand beneath their feet is only a thin layer above a black abyss. But there is one fortunate factor, a faint light in the darkness. Phoenix A asterisk is 5.7 billion light-years away, and no matter how powerful it is, its gravity or radiation cannot reach Earth in any immediate way, even if it exploded right now, which is impossible because black holes do not explode. We would know nothing about it for another 5.7 billion years. But that safety does not soothe the fear on a spiritual level. It only shifts the fear from a direct threat into a deep cosmic humility. You look at Phoenix A asterisk and realize that you are living on a small planet, in an ordinary star system, in a galaxy that is nothing special, and that all your tragedies and joys mean nothing before such ruler. Yet at the same time, that realization may also be a gift. You're alive in a brief moment of cosmic history, where you can look up and contemplate things you can never touch, and that makes your life more miraculous than any fear. However, do not think you're completely safe just yet, because after facing fixed monsters at the centers of galaxies, giants you can see, measure, even if imperfectly, and name, there is another thing, far more dangerous because it is not fixed. It is not at the center, has no blazing signature, no pleasant name. It wanders, it hides in the vast empty spaces, and it may be approaching without you ever knowing. It is a silent killer, a threat you will soon have to face, and its fear lies not in its size, but in the fact that it could appear at any time from any direction without any warning. 11. Magnetars, the magnetic field wall of destruction. We have talked about central monsters, colossal black holes sitting still at the hearts of galaxies, silent and patient. But there is another kind of danger, one that does not stay in one place. It is small, it is fast, and it can be anywhere in our galaxy. That is a magnetar. A magnetar is a special type of neutron star, the remnant of a massive star that died in a supernova explosion. When a star about 8 to 20 times heavier than the Sun runs out of fuel, its core collapses under its own gravity. Protons and electrons are forced together into neutrons. What remains is a sphere only about 20 kilometers across, small enough to fit inside a city, but containing 1.5 to 2 times the mass of the Sun. Its matter is so dense that a teaspoon taken from it would weigh about 1 billion tons, roughly the mass of a mountain. But a magnetar goes even further. Among all neutron stars, only about 10% are magnetars. What makes them different is their magnetic field, so powerful that nothing in human life can compare to it. To see the difference, Earth's magnetic field is only about half a Gauss, The Sun's is a few Gauss. An ordinary neutron star may already have a magnetic field of 10 to the 12th Gauss, but a magnetar can reach 10 to the 15th Gauss, about 1,000,000,000,000 times stronger than Earth's magnetic field. That number is so large it becomes meaningless, so let us describe it by its consequences. A magnetar could erase the magnetic strip on a bank card from a distance equal to 1/4 of the way to the Moon. It is strong enough to distort atoms themselves, pulling the electron clouds around nuclei out of shape, turning ordinary matter into a strange state that exists nowhere on Earth. And it is powerful enough to bend space-time around itself, something normally associated with black holes. That magnetic field is not only strong, it can erupt. A magnetar can release violent bursts of gamma rays, streams of radiation powerful enough to wipe out life on a planet thousands of light years away. In 2004, astronomers witnessed such an event, SGR 1806-20, an eruption from a magnetar 50,000 light-years from Earth. That explosion was so powerful that it still affected Earth's upper atmosphere, after travelling 50,000 light-years to reach us. In 1/5 of a second, it released more energy than the Sun emits in hundreds of thousands of years. If an explosion like that occurred within a few dozen light-years of us, it could rip apart the ozone layer and trigger a mass extinction. And here is what makes magnetars terrifying in their own way. Every previous danger was enormous and far away. A magnetar is tiny, only a sphere the size of a city, but it carries a power that can reach across a galaxy in a single instant. It is the closest thing nature has ever made to a destruction switch. Silent for thousands of years, then, in a fraction of a second, flaring brightly enough to shake the sky of a planet tens of thousands of light-years away. And a planet struck by it would never see it coming, because gamma rays travel at exactly the speed of light, so the message and the sentence arrive together. Scientists estimate that the Milky Way contains a few dozen magnetars. We have identified only some of them. The rest are somewhere out there, silent in the dark. But there is one thing to say clearly so you can feel calm before closing your eyes. No known magnetar lies close enough to threaten Earth. The nearest ones are still thousands of light-years away, far too distant to harm us. Their power is real and terrifying, but it belongs to distances the mind can barely touch. Tonight, the sky above you remains as peaceful as it has always been. A magnetar is not the only predator hidden in the dark. There is another kind of killer, quieter, harder to detect, and giving off no light at all to warn us. 12. Rogue black hole. The silent killer that is the rogue black hole. A wandering black hole. Unlike Sagittarius A*, which sits at the centre of the Milky Way, a rogue black hole has no home. It is a drifter, born from the chaos of the universe itself. Scientists believe there are two paths that can turn a black hole into a wanderer. The first happens when two galaxies collide. The supermassive black holes at their centres wrestle with each other through gravity, and sometimes one of them is thrown out of the galaxy at speeds of up to thousands of kilometres per second, becoming a drifter through intergalactic space. The second path comes from the death of a massive star. If the supernova explosion is unbalanced, stronger on one side, it can kick the newly formed black hole away like a bullet, sending it racing through the galaxy without a destination. And here is what makes them frightening in their own way. You cannot see them. Black holes emit no light. The only way to detect a rogue black hole is when it accidentally betrays itself, when it consumes matter from a companion star, or when it passes in front of a distant star and briefly bends that star's light, an effect called gravitational microlensing. In 2022, astronomers announced the first detection of a rogue black hole using exactly that method. It lies about 5,000 light-years from Earth, weighs about 7 times the mass of the Sun, and is quietly drifting through our galaxy, completely invisible, revealing itself only for a moment as it bends the light of a star behind it. An object 7 times heavier than the Sun, drifting 5,000 light-years away from you, yet no one can see it, hear it, or feel it. We only know it exists because a distant beam of light was bent slightly. And here is the part that makes people fall silent. Scientists estimate that the Milky Way may contain millions of rogue black holes like this. Millions. And almost all of them remain undiscovered, drifting somewhere out there, invisible and silent. But there is one thing that must be said immediately to put you at ease. Our galaxy is so vast that it is almost empty. The distances between stars are unimaginably large. The probability of one of these black holes coming near the solar system is so small that it is practically zero, and even if it happened, it would take timescales longer than the lifetimes of stars. Tonight, and for countless nights after, you are completely safe. What is frightening about a rogue black hole is not that it wants to hurt you. It does not know you exist. It has no intention, no goal, no hatred. It simply exists and drifts according to the silent laws of physics. And it is precisely that absolute indifference, a universe operating without the slightest concern for you, that makes humans feel so small. But there is another side to that same truth. If the universe does not care about you, then it is not against you either. You are free to find your own meaning in the brief and warm time you are alive. And the rogue black hole is still not the final thing hidden in the dark. We have talked about dark flow, the mysterious current pulling galaxies towards an invisible point. Now, after knowing about these invisible wanderers, you may see dark flow in another light. Perhaps it is not a flow, but a trace. The trace of something that has passed, is passing, or will pass. And if so, we are not only being pulled, we are being carried along by something far greater than anything the naked eye can see. 13. Edge of the observable universe. The boundary of ignorance. We have travelled through empty regions. You have felt invisible forces. We have stood before the final boundary of perception. And now you approach the very edge of everything. The edge of the observable universe. It is not a wall, nor is it a physical boundary. It is a boundary of light. The farthest mark that light has had time to reach you from since the universe began. Our universe is about 13.8 billion years old, so light has had only that much time to travel. But because space has expanded throughout that entire time, the true distance to that edge is not 13.8 billion, but about 46.5 billion light years. Standing on Earth and looking in any direction, you can see a sphere with a radius of 46.5 billion light years. That is the entire universe you can observe. But beyond that sphere, there may be countless things, other galaxies, other universes, even other laws of physics, we do not know. And the fear here is unlike any place you have visited. It is not fear of something dangerous, but fear of something forever beyond the reach of understanding. You will never know, because light from beyond that boundary simply has not had enough time to reach you. And there is an even deeper layer of loneliness. As the universe continues to expand, at very great distances it expands so quickly that galaxies out there recede from us faster than light can catch up. One by one, they will slip from our view forever. Billions of years in the future, living beings on some planet will look up at the night sky and see only the stars in their own galaxy. Every other galaxy will have vanished from sight. They will grow up believing that the universe is only that much, never knowing that there was once a sky crowded with other galaxies. Right now, as you lie still in the gentle darkness of your room, that universe is still quietly expanding. Distant galaxies are still drifting away, moving a little farther each night, like the lights of a ship fading into mist. But there is comfort in this. You're living at exactly the moment when the sky is still full of light, when galaxies are still there for you to see. You're one of the lucky generations able to see the universe while it is still bright. But there is another future. Farther, colder, and darker. A future where even the stars no longer burn. That is heat, death. 14. Heat, death. The coldest ending. Now we arrive at one of the most sobering ideas in all of cosmology. A future where everything comes to an end. Heat, death. This is not an explosion, nor is it a collapse. It is a fading. According to the second law of thermodynamics, in a closed system, entropy, the measure of disorder, always increases over time. The universe, therefore, is drifting very slowly from order toward disorder. Everything gradually breaks down, cools, and becomes more uniform. Then one day, Trillions upon trillions of years from now, the universe will reach thermal equilibrium. The same temperature everywhere. No temperature differences, no flow of energy, and therefore no life. No stars, no planets, no galaxies. Only a cold, uniform darkness stretching endlessly. It is an ending that comes not from catastrophe, but from simplicity itself. No longer enough energy difference to sustain anything. The stars will gradually go out. The last stars will burn through their fuel and cool into dark remnants, black dwarfs. Then even black holes will evaporate unimaginably slowly through a process called Hawking radiation, lasting so long that the human mind cannot contain it. And in the end, nothing will remain. No light, no warmth, not a single movement. Scientists estimate that the universe will reach this state after about 10 to the 100th years. A number 1 followed by 100 zeros, so large that simply writing it out is longer than many books. But no matter how enormous it is, it still has an endpoint. Hearing this, you may feel a very quiet smallness rising inside you. You're lying here, on a small planet, in a small galaxy, in a universe that will eventually fade, and there is nothing you can do to stop it. But there is another way to see it, one much warmer. Heat death is so far away from you that it does not belong to anything you need to worry about. Not tonight, not even millions of generations from now. And precisely because light, warmth, and life are rare things that will one day pass, this moment, the warmth of the blanket, the quiet of the room, the rhythm of life flowing through you, becomes even more precious. You are living in the brightest chapter of the cosmic story, while the stars are still burning. Tonight you have taken a long journey. You have seen voids, invisible forces, collapsing boundaries, central monsters, hidden killers, and the edge of everything. But perhaps the most important thing you have learned is not about the universe. It is about yourself. You're not only a tiny creature on a tiny planet. You're part of the universe. You're the universe becoming aware of itself. And every time you look up at the night sky, every time you think about the stars, you're connecting with something greater than yourself. And that is the most beautiful thing science can teach us, that we are not alone, not because someone else is out there, but because we're part of the universe. We have always been part of it. Close your eyes, feel your breath, feel your heartbeat, feel your own presence in this moment, and when you sleep, when you dream, know that the universe is still there, still expanding, still holding mysteries we have not yet discovered, but you're here, now, and that is enough. If these stories have brought you a little peace, a little curiosity, or a small sense of connection, subscribe to Space Lull so we can continue the journey together. And remember, the universe is always with you.